Hey everybody, welcome to this video presentation on Microsoft 2008 R2 CA Part 3. This video builds on Part 1 and Part 2 of implementing an SSL certificate. In this video, what we're going to do is bind the certificate to the website. And what I've been doing in this video presentation is trying to give everybody a very simple analogy of how this works by using a state licensing agency as my analogy. So as I go through the presentation, I'm going to be referring to this analogy. So if it doesn't make sense, maybe you want to go back and watch Part 1 and Part 2. But I think for the most part, you'll be okay with this. So what we're going to do is start out with an introduction here to kind of refresh you with what we did in the previous videos. We've got an Active Directory environment, number one. Everything's 2008 R2. We have an enterprise root CA, and everybody's a member of the domain. We've already installed and built the enterprise root, and we've already made the request from the server for a certificate. And the analogy that I've been using is like a shopping center. So the server, MS1, right here, acts as the shopping center. And in that shopping center, we can have a bunch of different businesses, like in a strip shopping center where you have like an eyeglass store, a small restaurant, a barber shop, those type of things. And the businesses would be the different websites, because in IIS you can have multiple websites on one server. When you make a certificate request, the request actually comes from the server. It doesn't come from the website, which might seem a little odd, I guess. You would think that the website would be making the request, but the way it works in IIS is the server makes the request for the certificate, and the certificate is stored on the server. And then what you do is you bind the certificate to the individual website. And the way you can have multiple websites on one box is by having either a unique IP address, port number, or a host header name. Those are the ways to make that website unique. So what we're going to do is we're going to use this analogy of this shopping center. And basically what we've done is we've already established that the owner of the shopping center has made some kind of an arrangement with all the different businesses that when they lease space from him, what he's going to do is he's going to go out as part of the lease, as part of the cost. Of course, they pay some kind of money for this service. The part of the cost of having the lease is that the owner of the shopping center, after they've been in the center and they've signed the lease, he's going to go out and get that license they need for their business. Now, I know in real life that that's not the way it would work. I know in real life that the owner of the business would go get their license for operation, but just for the sake of the analogy, we're going to say that the owner of the shopping center is going out and getting these business licenses for these tenants in a shopping center. So where we're at right now is the owner of the shopping center has already gone out and got a license for one of the businesses. But what he hasn't done yet is walked over, knocked on the door, walked in and hung up that picture frame that has the state license in it and hung it on the wall. He hasn't done that yet. So what we're going to do is go ahead and do that in the computer world. In this Microsoft specific example, we're going to bind the certificate to the website the same way the business owner of the shopping center would hang up the picture frame with the license in it in the business. So that's the analogy, and I think that it will work. So the certificate is actually at this point, the certificate has indeed been installed on the server. So the request has already been made. The certificate was built from the web server template. The public key was added to the certificate. It was signed using a private key using this encryption method, which we determined during the initial install of the server. And we do have the certificate in our hands. So as the owner of the shopping center, I have that certificate. Now I'm ready to actually bind it to the website. Or as the owner of the shopping center, I have the license. I'm ready to hang it up. In the IIS world, I have the certificate. I'm now ready to bind it. So what we're going to do is switch over to the server. And we're on member server 1. We're right here. This is the server. I want to emphasize that we're at the server. And this is where we made the initial request. Initially, we created a domain certificate request and went through a very quick process because we had an online enterprise CA, and we've obtained the certificate. So I have the certificate. The business owner, the shopping center owner, the shopping center owner, the strip shopping center owner has the license. or the server has the certificate. And what we're going to do is bind that certificate to the website. In the analogy, the owner of the shopping center is going to take that license, put it in a picture frame, walk over, knock on the door, and hang up that license. So I'm about ready to knock on the door. So I'm going to right click and edit bindings. Or I can go to the action pane and click bindings. Either way would work. And I'm going to click add. And I'm going to choose type HTTPS, very important. I choose the right IP address, kind of like the address of the actual tenant in the shopping center. Make sure I got the right port. And this is where the magic happens right here. This is where we do the binding. So the certificate at this point is just sitting on the server. It's not really being used by anybody. Any website on that server could bind that certificate, but you got to remember though that that certificate, even though it wasn't bound, when we made the request for the certificate, it was a particular type. It was a web server certificate type. Also, it has the common name information for the website embedded in the certificate. So even though I could bind it to another website, it wouldn't really work. It'd be kind of like if I got a license for a business. The name of the business is going to be on that license. So if I'm the owner of that strip shopping center, and I took that license and I walked it into the wrong business and hung it up, if people walked in and actually inspected the license, the name on the license wouldn't match the name on the door or on the sign in front of the building. So you do have the ability to mistakenly bind the certificate to the wrong website. Just like the owner of the shopping center could mistakenly walk the license into the wrong business. So even though the certificate is on the server, and you could bind it to any website, it doesn't really make any sense to bind it to any other website than the one that you specifically made the request for, if that makes any sense. And I'll show you more in that in just a minute. So we're going to close that out. So we bound the certificate to the website. Now if I click on the server, let me just kind of prove my point here just a little bit more. When I look at the certificate that I just bound to the website, when I view that certificate, I can see the details of the certificate. And the most important thing here would be the subject name information. See how it shows www.coolweb.local? That information was in there before I ever bound the certificate. So if I was to bind that certificate to the wrong website, when people go to the website, they're not going to be typing in coolweb.local, and they're going to get some warning messages are going to pop up that that's not going to work. So that's really, really important that we bind it to the right website so it matches the subject information. We can see that it's an X.509 version 3. We can see that it's unique with its serial number. We can see the signing that was used on this certificate. Now the signing is something that occurred when we actually made the initial request. So the issuer of the certificate or the state agency that created the license put their stamp on it, their seal. They signed it with SHA 256 RSA based signing algorithm. So basically a signature is a hash that's created and then encrypted and attached to the certificate. So you can see the technology that was used there to do that. We can see who issued it. We can see it was the enterprise root. We can see how long it's good for. We have till April 10th, 2014. Again, the subject information. And there's the public key. There it is. There's your public key information. The public key is used to encrypt data. The private key is used to decrypt data. Now, the public key could also decrypt with the private key encrypts. So we could actually have the public key decrypting and the private key encrypting. But we like to do it this way where the public key encrypts and the private key decrypts, because the private key is kept secret and kept safe on that machine and never leaves that box. So there's your public key. And this public key, the main idea is that it's used as something that's plugged into an algorithm that does the encryption. So the bigger the key, the better the encryption is going to be. We're only using 1024. For an internal website, that's probably good enough. If you were looking at a more publicly accessible website, you might want to raise that up to like 4096. It does make it a little bit slower, but we're talking milliseconds, right? Something else we're going to spend some time on later in the part 4 video, I'm going to explain to you what a certificate revocation list is, but I'm going to talk about it a little bit here because I think it's kind of important in the AIA. But I am going to dive into more details on those guys later. And basically what's going to happen is that embedded in every single certificate is the CRL, which is also known as the CDP, or the certificate revocation list distribution point. Let me write this out a little bit bigger up here so we can see this, because this is very important, I believe, to understand what's going on. So embedded in every certificate is the certificate revocation list distribution point. And this basically is a LDAP path by default. And you can change that. You can change that to like a web path, a file path. You have some different options for what that path is going to be. And by default, that revocation list is going to be published into AD. So the CRL, which is just a file, that's all it is. It's just a file that has a list of all the revoked certificates. That file is stored by default up here in Active Directory. The path to that file is what's included in the certificate. Also included in the certificate is the path to what's called the AIA, Authority Information Access, which really isn't so important because we already know who the authority is, who the issuer is, which is the enterprise root. And that's already known because that certificate was published into Active Directory. So that's already been done. So that's already known. So the AIA in this example is not as important. If I had a multi-tiered CA hierarchy, that AIA would be a lot more important as we go through that. Let's see how the interaction works with the workstations. We're going to go over to the workstation. So in the properties of the browser, I go to Tools, I go to Internet Options, I go to Content, I go to Certificates, I go to Trusted Root CAs, and bam, right there you can see it. This client already knows who the root is. So there's no question about going to this website where this website got the certificate from. He already trusts that server that signed that certificate. And that's where that signing comes in, why it's so important. We're going to a website that has a certificate that was signed by a root that we know about. So if I were to make the analogy to the strip shopping center, if I'm a customer that comes into the business and I look at the license on the wall, I can see that it came from a state agency that is trusted. So there was some state agency out there that would play the role of the CA that generated the license, signed it, stamped it with the state seal, and then the owner of the shopping center came up and bound it to my business. So there's some kind of inherent trust that I trust. For example, I live in the state of Florida, so if that license has a seal from the state of Florida, I trust that license is in that business's storefront. It gives me some sort of trust. Also, the common name is good. The common name is the information we typed in when we initially made the certificate request. So when I'm at the client, when I put in the URL information, it matches the common name in the certificate. So I typed in coolweb.local. Embedded in the certificate that's been bound to the website, back on the server, is that name. And I can see that in the common name information. Common name equals www.coolweb.local under subject. Very important. And that's what ties that together. So that matches. The certificate has not expired and has not been revoked. So when I make the connection from the workstation to the server, all those things are checked. Now the other thing that was checked, which will lead me into the next video, is that the certificate is brought down, or a copy of it at least, is brought down to the client. So when I made the connection, the certificate that contains the public key traversed the wire and was brought down to my workstation. Now in that certificate, I know the path to the CRL. Now the AIA is not quite as important because I already know who the issuer is. The AIA is a really difficult thing to understand. It stands for Authority Information Access, and all it means is that we know who the issuer is. I already have a copy of the root CA certificate, so the AIA is good. I don't really have to worry about it. But what I am going to check is I'm going to check this path that's included. Let me just write the word path in there just to make sure it's clear that I'm including the path information. Embedded in the certificate is the path to this CRL. So I'm going to go to Active Directory because by default this path is going to be an LDAP path. I'm going to go to Active Directory. I'm going to find the CRL. I'm going to make a copy of it. And I'm going to bring down a copy of that CRL. Now, depending on how many certificates are being issued, the CRL list could be very, very short or it could be very, very long. If I had an organization issuing thousands of certificates, of course that revocation list over time can get pretty big. But for what we're doing right here, the CRL is going to be tiny. It's going to have maybe 2 or 3 things in it, depending on what's been revoked on the server before. I download the CRL, and I'm going to check to see whether or not this certificate is still valid. In other words, does this certificate show up in this list? If this certificate doesn't show up in this list, I know that it's good. Then I establish my SSL connection. So the analogy to the state business would be, I walk in, I see this state license plaque. Before I do any business with that company, I'm going to go to the state agency and check and see whether or not they revoked their license. Because they could have that license on their wall still be doing business even though the state has revoked their license. It's very possible. You hear all these weird stories all the time on the news about like doctors' offices running businesses and they appear to be legitimate but they're not. You know, those type of things. You can make that type of an analogy with that. The thing that's really cool about it though is just the way the technology works. When you download the certificate, embedded in the certificate is the path to where that revocation list is. And it's not really much of a stretch for an analogy. Like if you walk into a business, if you really want to find out whether they're really licensed or not, you know where to go to find out if they're really a valid business, whether that license was really issued, or if it was, if it's still good, right? And you definitely can do that. The thing that's different in computer technology is you're forced to go check it before you can begin doing that transaction. In the real physical world, you might walk in, look at the license and never bother to check to see whether the license is really good or not. In the computer world, you're forced to go check by checking that revocation list. And then the SSL connection is started with the business. Then you as a customer start doing business with that company. Right? If you're really, really, really going to be particular about who you do business with, you would check them to make sure they're really a valid licensed business, especially if it was a doctor's office or something like that, or maybe a hair salon or whatever the simple analogy might be. So that gives you a pretty good idea of how that works. So just to summarize, we've bound the certificate to the website. Let me just go back and show it real quick once. So we bound the certificate to the website. So you go to the server and we went to server certificates. We see that the server requested the certificate. Then we bound it. We can see under bindings that it's been bound. And then we went to a particular folder and we required SSL. Oh, we haven't done that yet. Let's require it. Let's apply it. Let's go back to the workstation. And now let's try to go to, of course, the initial site, HTTP is no problem. Now we're going to try to go to data, and now we're requiring SSL. Now the analogy here would be that I have a back door to the business, and this one door has 2 different ways you can access it. You can access this one door either through an SSL connection, where it's encrypted and safe, or it can be wide open. If I don't require SSL, let me go back and just uncheck that one more time and apply it. If I don't require SSL, you can actually connect without the S. Or you can connect with the S. So in either case, you can make the connection and everything's good. But if I require SSL and apply that, and now we go back, so I'm going to connect without the S to coolweb.local, without the S to data. And because I now require SSL, there's like a sign that is now hanging on the back door, and the sign says, you can only connect with SSL. Or maybe there's a sign on the back door of the business that says something like authorized personnel only, right? Or employees only. If you're not an employee, you can't come in through the door. If you don't want to connect with SSL, you can't connect in. The analogy might be something like there's a canopy on the business on the back. And then in order to do any kind of transaction, we want to keep it secret and safe so nobody can see the transaction taking place. So the only way you can connect is with SSL. If you were to drive your car up to that backdoor entrance and you said that you want to do a transaction but you don't want to do it in secret, they wouldn't let you connect. You can only connect if you're going to do it in secret and you're going to do it with an SSL connection. You can't do it any other way because we require SSL at this point. So now all I got to do to solve that problem is put in the S, and now the connection is established. We meet all the requirements because we know who the root is, the common name matches, the certificate has not been expired and is not revoked because we downloaded and checked the CRL, everything looks good, and we established the connection. Just like that. And that's the process of how that binding and requiring works. Now in the next video, what we're going to do in part 4 is we're going to take a look at how the encryption goes on back and forth between the server and the client. And I hope you stay tuned and check it out. It's really cool stuff. We'll see you in part 4.